Alright, so we're going to put that in there yet. Make sure you get that word in there. 96 dilations. You have finished?
Ella me la devolví. No. Yo lo voy a pagar por ellos me dijeron
Alright, so 96 dilations. Where have you heard that word dilation before? In your eyes. If your eyes dilate, take out your notes, student. Oh, do your mind. Following. Notes out. Alright, if your eyes dilate, if your pupils dilate, what does that mean? What would that look like?
They're getting smaller or bigger.
Yeah, they're getting smaller or bigger. That's really all we are doing today. So we're making things smaller or bigger. But we're going to be doing it proportionally. So it's not just one part of the shape that's going to get bigger. The whole thing itself will get bigger. So a dilation is a transformation to make a shape bigger or smaller. And to do that, we use multiplication. So today, if you have a calculator, it's easy peasy. So you got out a cutout. If you want to just trim it a little bit, you can probably fit it all in one area. So you can go ahead and glue that in. If you need to, you could maybe just spread them out on one page. You do want a little bit of space to work for each problem. Okay, so go ahead and glue that in. Maybe do a little trimming. I'm just going to trim a little bit up off the top, off the bottom, and then I have enough space. And glue that in. Okay, if you don't have enough space to glue it from top to bottom, I just trimmed the top of mine and the bottom of mine and it fit. If yours doesn't fit, you might need to cut it apart, but you don't need a whole lot of space, but you do need some space. You might need to cut it apart and put the bottom one on the next page, or you could put it side by side. Okay, so give you about 45 seconds to get that done, get that glued in. Test is next Tuesday. Alright, so get that glued in. Okay, it started in about 30 more seconds. Alright, so while we do a dilation, the very first thing that we are going to do is we are going to identify the ordered pairs because we need to know the x's and y's. So for this first one, we have B, C, D, and E. And we're going to write down those ordered pairs just like we did when we did a rotation. Okay, when we did rotations, we like to do those ordered pairs. So, Lara? Okay, so what is the ordered pair for B?
For B?
Yeah, B.
-1, 0.
Good. It goes left 1, and then doesn't go up or down, so -1, 0. Okay, what about C? -1, +2. Remember, we're always starting at the origin here. Okay, what about D? +2, +2, yep, 2, 2. And then E?
1, -2.
1, -2. Sadiq, put away your phone. Last time I'm going to ask you. Alright. So, what our scale factor is, the scale factor is what we're multiplying by. So when we use multiplication, we use the number it's telling us to do. So we use the scale factor, which just tells us what are we going to multiply by. And in this case, it tells us that we're going to do a dilation of 2.5. So we're just going to take all of these numbers and we're going to multiply it by 2.5. So we're going to have B prime, C prime, D prime, and E prime. And all we do is multiply by 2.5. So I'm going to pull out my calculator. Don't even need to use Desmos. Okay, -1 times 2.5 is -2.5. Now I have a 0. 0 times 2.5 is 0. -1 times 2.5. If you forgot what that was, we just did it. But if you forgot, guess what? You just put it back in your calculator. -2.5. 2 times 2.5 is 5. And we just did that. 2 times 2.5 is 5. 2 times 2.5, 5. What's 1 times 2.5? 2.5. And then what about -2 times 2.5? Yep, -5. Again, if you don't know those, guess what? You just put it in your calculator. Well, bammy. It's done. Alright, so now we're going to plot these. So the biggest part of this is plotting the 0.5s, or if you get like 3s or 0.4s. So for this one, we're going to start at 0. We're going to go left -2.5. So I'm going to go left 1, 2, and then an extra half. And it doesn't end up right on a line. It goes in between the two lines. Okay, so I went left 1, 2, and then an extra half, and that's B prime. Okay, for C prime, it's the same thing. I'm going to go left 2.5, but then up 5. So I'm going to go left 1, 2.5, and then I'm going to go up 1, 2, 3, 4, 5. And there's my C prime. Okay, D prime, that one's easy. It's 5, 5. They're both positive, so we're going to go right 5, up 5. It ends up being right in the corner. And then we have E prime, which is right. It's positive 2.5, so to the right 1, 2.5, and then down 5. 1, 2, 3, 4, 5. Hi, you finished? Perfect. Alright, and then you can use your ruler, to straight edge, to connect those points. Thanks for finishing. Appreciate that. That way we just don't have to have a missing assignment. Where are you headed? Okay. Oh, Koskinen. Yep. Did you miss lunch? You're about to have lunch. Okay. Alright, so go ahead and those lines. Alright, so overall, the picture got bigger, right? It increased. So the whole thing increased proportionally, meaning it was like if we made it wider, we also made it taller. It wasn't just it got just wider. Why is it not? Oh no. Okay, so that's the big thing here. Yeah, you're on the list. I'll let you know. People still using the pass. Alright. This about the origin. What that means is that we're starting at the origin, and that's how we found all these points, is that we're just starting at 0, 0 and counting to those points. If we wanted it about a different point, if it's like about 1, 3, we would go to 1, 3, and we would find all these ordered pairs from that point. 1, 3 is here. Okay, but today, since this is the first time we're doing dilations, it's always going to just be about the origin, so you just have to worry about finding your ordered pairs normally. Okay? Alright, so the next problem is very similar. This time, we're going to be multiplying by 0.25. So what's going to happen in this problem when we multiply it by 0.25? Is it going to get bigger or smaller? Why? How do you know when it's going to get smaller?
Because you're multiplying by like 0.
It's a number less than 1. So if we're multiplying by a number less than 1, it's going to get smaller. Okay? First thing you need to do is identify your points. So we have T, U, V, and W. So I'm going to give you some time. Try and find all your ordered pairs. And then we'll go through it together. Some people are still struggling with getting those ordered pairs correct. So that's a really important part of this chapter, especially on those rotations and dilations, that you can find those ordered pairs. So much fun. Guys, do you want to practice? Thanks. Alright, what is our ordered pair for T? If I start at the origin, the middle, do I go left and right at all? No. So it's going to be 0 first and then -2. I can add you to the list. Probably go really quick because there's multiple people behind you. No. Never.
Huh?
Never. There's so many people that always have to go to the bathroom. There's so many people. Alright, you're on the list. Alright, what about you? -2, +1. V? 1, 2. Good. +1, 2. And what about W? 3, 0. Good. Now we're literally going to take every one of those numbers and we're going to multiply by what? 0.25. Okay, so for T prime, we know 0 times 0.25 is 0. Okay, -2 times 0.25 is -0.5. If you're paying attention, we just did -2. We just did that, so that's going to be the same, -0.5. 1 times 0.25 is 0.25. That's what we just did here. 1 times 0.25, 0.25. There's some. Three times 0.25. Cody, do you mind? Alright, and 0 times 0.25 is 0. Alright, and then you're just ready to plot those points. Everything by 0.25, we are good to go. So 0, negative 0, the origin. We don't even go a full line down. We just go half a line down. So from the origin, we're going to go down half. And there's our T prime. Okay, U prime is negative half, so we're going to go left a half and then up a quarter. So left a half, and then we don't even go half. So using a sharp pencil is nice for this one, because otherwise you just get really big dots. AR mechanical is nice for this one. Okay, V prime, we get 0.25, so that's positive 0.25, and then half. So we go right just a little bit, and then up a half. And then we have W prime is 0.75, so it's not even all the way to 1, but it's more than halfway. So try and get a little bit more than halfway, but not all the way to 1. Then we have that teeny tiny little quadrilateral. And that is a quarter of the size. Super cute, right? Okay, when you do dilations, what do you notice about the points? Like if you look at V, what quadrant is V in? You guys remember what quadrant this is? Quadrant 1. Where does V prime end up in? Quadrant 1. W was on the x-axis, so where does W prime end up? On the x-axis. So when things are getting bigger or smaller, and we're doing it around the origin, about the origin, things should end up generally in the same area that it started. Okay? So if your V is sudden down here, or your V is all of a sudden in this quadrant, something's not quite right. Okay? Alright, last one. And you have the rest of the time to work. Alright, in our last one, we are going to find the scale factor. It's already drawn for us. We need to decide what number did they multiply by to either make that shape bigger or that shape smaller. So which is the pre-image? Which is the image before the dilation? Is it the smaller one that's kind of on the inside or the larger one on the outside? How do you know it's a smaller one on the inside? Good, it doesn't have the primes. So if you need to highlight that one so you know where you're starting, you could. We're going to start with this one. And we're going to end at the one with the primes. Let me pretend I have a highlighter. Alright, so in this one I'm going to start at the pink and I'm going to go to blue. I just highlighted them so we can make sure that we're talking about them right. How many points do I really need to use? I really just need 1 point. I can check with 2 points. But if I can figure out how to get to 1 point from the original, what I'm multiplying by, then we're good to go. Okay, so Which point is going to be the easiest to look at? The x and x prime, y and y prime, z and z prime, or w and w prime? Which two have a pair that both points are nice to look at? W or z? Why is x not a great point to look at? Yeah, and we could assume it's about halfway, but we don't know. It might be like a 0.6 or a 0.5 or a 0.8. So we want to pick those points that have nice points to work with. So let's do both w and z, just to make sure. So w starts at -2, 0. And what does w prime end up at? W prime is -3, 0. Okay, and then I can think z, if we wanted to check z, z is 2, -2. And z prime is 3, -3. So I need to think, what am I multiplying by to go from point to point? So -2 times what is -3? And if we're not sure, we can use the inverse. What's the inverse of multiply? Dividing. So I'm going to take -3 and divide it by, yep, I'm going to go backwards. I'm going to start where I end, and I'm going to do the inverse. So -3 divided by -2. And we get 1.5. So that should be what we're multiplying by, is 1.5. Because when we divide backwards, we undid the multiplying by dividing. We get 1.5. So let's just double check down here. If I take 2 and I do 2 times 1.5, yep, that gives me 3. -2 times 1.5 would give me -3 also. So our scale factor is 1 and 5/10. It got bigger, so we know it has to be bigger than 1. Okay, but big thing here is when we're doing this, we have to identify where we're starting. We're starting with the pink here, and we went to the blue. If you go the opposite way, what's going to happen? Yeah, it's going to be the inverse of it and make it smaller. We want to make sure that we're going in the right direction, and in this case, we're making it